Question 2 is an exam question. It says a large stone block is to be part of a harbour wall. The block is supported beneath the surface of the sea by a cable from a crane. Figure 2.1 shows the block with its top face a distance h beneath the surface of the sea. The force acting downwards on the top face of the block due to the atmosphere and the depth h of the water is 3.5 times 10 to the 4 newtons. The top face of the block has an area of 0.25 meters squared. Calculate the pressure on the top face of the block. We're going to use the equation pressure is force over area. We need to rearrange this. No, we don't need to rearrange this. So this is 3.5 times 10 to the 4 over 0.25. Just checking the units. This is in newtons, this is in meters squared, so we don't need to mess around with the units. This should give us an answer of 1.4 times 10 to the 5 pascals. Part 2, the atmospheric pressure is 1 times 10 to the 5 pascals. Calculate the pressure on the top face of the block due to the water depth, due to the depth h of water. So here we're using the idea that the total pressure is caused by the pressure from the water plus the pressure from the atmosphere. Therefore, the pressure, so this is the total, the pressure just from the water should be equal to the total pressure minus the atmospheric pressure. So if we can see from here, this we could write as 0.4 times 10 to the 5. We'd probably usually write it as 4.0 times 10 to the 4 pascals. But if you wrote 0.40 times 10 to the 5 pascals, this is an acceptable answer in physics. In maths, we don't like standard form numbers written like this. In physics, that's fine. The density of the seawater is 1020 kilograms per meter cubed. Calculate the depth h. So we're going to use the idea that the pressure caused by the liquid is rho gh. We want to find h. So that's equal to the pressure divided by rho g. So this is 4.0 times 10 to the 4 divided by the density 1020 multiplied by the gravitational field strength, which is 10, which gives us a depth of 4 meters, 3.9 meters, or 4 meters, depending on what value of g you've used.